Hello, my name is Emmett Spaeth, and I'm from the 1991 Dragons, and today I am presenting state machines in FRC programming. I've been the programmer and driver for the Dragons for the past 2 years, and that's impacted a lot in my development cycle. And throughout that time, I've developed the state machine, and I want to share that with you guys today. So let's start out with a brief history on how this came about. Why did I make it? The biggest reason I'd say is that we don't have a programming mentor. And we haven't for as long as I've been on the team. So when I'm faced with an issue, with some bug, if I can't solve it, it will not be solved. So if we're at a competition and our swerve drive code throws some kind of error or some bug, undesired behavior, if I don't figure it out by the next match, I kind of have to look at the team and say, hey, we're not driving this match. So I wanted to develop a system that was very stable and very, very hard to create bugs in. Next reason was I always have very little time to program. I was very happy to get a full day this season, and I'm sure this is something all the teams have to struggle with, where they have very little time and they need to program a robot really quickly, and I think that this is going to help. I'm a solo programmer, so this is going to be a very, very simple system that anybody can implement, even if you are a solo programmer, even if you just started out. This should be just as simple as doing commands and subsystems or a time-based robot. We're going to break it down to easy, bite-sized pieces that anyone can do. Of course, I originally programmed using the command-based paradigm, because that is the most prevalent style of programming right now, and it's all in Java. I think there's been an FRC blog that like 70% of teams use Java, and the large majority of that is command-based programming. And the final thing is, I think there's a lack of resources for middle-level teams to step their game up into a higher level of play. See, I'm talking about teams that don't necessarily build a kit bot, they don't build an every bot, they build their own robots, but they still have to worry about being picked at alliance selection. Or if they do get picked, they usually get picked second and play defense. So I really want teams like that, a team like us, to be able to perform better by having a better control scheme. And so hopefully that's what the state machine is going to be able to do for fellow FRC teams. So to start out, let's put a disclaimer. I did not create the idea of a state machine. That is not mine. I'm sure other teams have done it, and I'm sure their code is open source. I found out about it on a Wikipedia page on control theory when I was researching different ways to control the robot. So I'm sure you could Google it, and you'll find the Wikipedia page I looked at. What I'm presenting is my implementation of the state machine idea for specifically FRC, and the specific way that I have made it. So the next question is, why should you care? Right, you being the viewer. Well, the real answer is maybe you shouldn't. It kind of depends on where you are. If you're in a really top level team where you're absolutely sure you're alliance captains, you don't need to worry about making districts, this really isn't for you. I'm sure you have your own system, which will work much better than mine will. But this is for, again, those middle-level teams that really want to step their game up in control and have better, more stable, easier to debug code. This can also benefit rookie teams, even though I didn't make it with them in mind. I've realized as I'm making it that I was developing it for the programmers after me to make sure they had a solid system. So I've made it fairly easy to pick up and hopefully not very complex. So the goal is to make this for everybody. Now, of course, again, no programming mentor, so I'm sure I have picked up bad habits, and I'm hoping that you guys can help. And I'm curious what you guys think, you, the FRC community. There's lots of room for improvement, so please pitch in, let me know. If you have a state machine code base, of your own. If you've been doing this, please share it with me or share it with everyone. Hopefully we can turn this style of programming into the next, command-based paradigm. That way, it'll get, full support from the WPI library, and it'll make it easier for students to go and use it, making less stress on the programmers. Finally, if you want to look at the code right now, it's open source. We always open source on Team 1991, no matter what quality the code is in. So, FRC 1991 is the GitHub account, and then Robot 2025 is the repository for this year. You can also look at past years. 2024, I was developing the code, so you could take a look at that. It also has a version of a state machine, but it's different from the one I'm going to be talking about here. So the plan is to break this whole presentation down into a series of different videos. The first couple will be explaining the idea. It'll be all theoretical. It'll be diagrams. It'll be in this slideshow. And then we're going to go through step by step through the entire code base. And it'll go much quicker than you think it will because of how simple the system is. And we'll compare and contrast with the command-based paradigm to see where does it improve on, where are its shortcomings, and then finally, how does it all work? So stay tuned. Please watch the videos. It's going to be a very, very fun time, and hopefully everyone can learn something from it, myself included.